Section 5.2 is about perpendicular and angle bisectors within a triangle. So Theorem 5.2 is the perpendicular bisector theorem. It says if a point is on the perpendicular bisector of a segment, so that means like P is on the perpendicular bisector, then it's equidistant from these endpoints. So therefore I know that this line segment is congruent to this line segment. The converse of it is also true. If I know that these line segments are congruent to each other, then I also know that this point is on the perpendicular bisector of the segment. Let's take a look at an example. So example 1 says, what's the length of AB? Well, I know that this is a perpendicular bisector since I have a right angle and I have two congruent pieces. B is on that perpendicular bisector, so it's going to be equidistant to these endpoints. So therefore, this line segment is congruent to this line segment. So I set up an equation where I did 4x equaling 6x minus 10. Excuse me. I subtracted 2x or 6x to the other side and got negative 2x. And then I solved for x by dividing and got x equals 5. Now pay attention here, it's not asking for what x is, it's asking for the length of AB. So then I had to take my AB expression, which is 4x, and multiply 4 times 5 to get the length. Alright, pause the video and try the next question. In the GOTA question, it's asking for QR. Q is on the perpendicular bisector, so that means that QR and QP are congruent to each other. So you should be setting up an equation where you do 3n minus 1 equals 5n minus 7. There's different ways of solving it, but I went ahead and subtracted 3n and got 2n, and I added 7 over here and got 6 and divided. So I got n equals 3. Doesn't ask for just n, it asks for QR. So I had to go back and plug in 3 for the n spot in my QR expression. So therefore I'm getting 15 and then subtracting 7, so I get 8. Okay, so if you flip your note-taking guide over, you'll see that you have angle bisectors on the back side. And so on the back side here, it says if a point is on the bisector of an angle, then the point is equidistant from the sides of the angle. So if S is on the angle bisector, then this point is congruent. These line segments are congruent to each other. The converse is also true, just like it was for the perpendicular bisector. So if this point is equidistant to the sides of an angle, then I know that S is on the angle bisector. So let's take a look at an example. Here you have a picture, and it wants me to find the length of RM. R is on the angle bisector. So since R is on the angle bisector, I know that these two line segments are congruent to each other. So I'm going to set up an equation where I do 7x equaling 2x plus 25. I'm going to subtract that 2x over, and then I'm going to divide by 5, so I get x equals 5. Again, it doesn't ask for x, it asks for RM, so I have to plug 5 back into this expression, and I get 35 as my final answer. Pause the video and try the next question. So F is on my angle bisector, and I know that these two line segments are now congruent, so I'm setting up an equation where I do 6x plus 3 equaling 4x plus 9. I'm going to subtract 4x, subtract 3, divide by 2, I get x equals 3. I need to plug that back into the FB expression. So I'm doing 6 times 3 plus 3, and I get 18 plus 3, which is 21. Okay, so pretty simple in terms of what the theorems are saying, but the pictures get kind of confusing. So keep in mind that you should have equidistant from either the point to the sides of the angle, or you should have equidistant from the end points to the point that's on the perpendicular bisector.